3 is on properties of logarithms. So like I said, we're going to be learning several new properties today. So yesterday I talked about how, or 2 days ago, I talked about how logarithms are related to exponents. Logarithmic equations are the inverses of exponential equations, right? So things that we had for exponents are going to be used for logarithms. Logarithms are actually exponents. We talked about that as well. So if I have a to the m times a to the n, it's a to the m plus n. We add our exponents. So for example, if I have x to the second times x to the fifth, we all know that that's x to the seventh. We've done that a million times. Okay, so similar properties are going to hold. When we have multiplication, it's going to be related to addition. Okay, so if I have log base b of m plus log base b of n, well, that's the same if I combine them into one logarithm as log base b of m times n. So multiplication and addition are related to each other. Okay? Whenever you need to think of an example, think of base 10. What if I have log base 10 of 100 and I add it to log base 10 of 1,000? Well, I know that log base 10 of 100 is what? Do you guys know that right off the top of your head? 10 to what power gives you 100? 2. Oh man, it's going to be rough later. All right, 10 to what power gives you 1,000?
3.
So this should be 5. So let's test. If I do my product property, I have log base 10 of 100, and I have plus log base 10 of 1,000. The product property is saying that we can combine those with multiplication. We can do log base 10 of 100 times 1,000. So 5 zeros. And that works. 10 to what power gives me 100,000? 10 to the 5. So see how it works. So you can always test whether or not something's true or false based on that. You cannot say that log base b of m times log base b of n is equal to log base b of m plus n. It doesn't work that way. Okay, you cannot say that. Like I said, when I say cannot, maybe I should have equals. You see what I'm saying? It doesn't work in that order. And you can always think back to the base 10s if you need to. Okay? So it says express log base 6 of 4 plus log base 6 of 9 as a single logarithm and then simplified. So if I have two separate logarithms and they're separated by a plus, we combine them by doing 4 times 9. So we get log base 6 of 36. 6 to what power gives you 36? 2. So remember, you can do the little shroopity-doop thing. 6 to the 2 equals that. All right, so the next one, I have log base 10 of 25 plus log base 10 of 40. So that's going to be 25 plus, oh, I almost messed it up, 25 times 40. Because we have two logarithms separated by addition, we combine with multiplication. So we get log base 10 of 1,000, which is 3. 10 to the 3 gives you 1,000. So likewise, when we had exponents, if I had x to the 5th divided by x cubed, I subtracted my exponents, remember? So the same thing is going to apply for logarithms. If I have division, I'm going to relate it with subtraction somehow. So if I have a to the m divided by n, it's going to be a to the m minus n. So if I log base b of m minus log base b of n, it combines into log base b of m over n. So division is related to subtraction. So when I see two separate logarithms, log base 5 of 100 minus log base 5 of 4, I can combine them as log base 5 of 100 divided by 4, which is log base 5 of 25. 5 to what power gives you 25? 2. So you should know right away what those are. These are typical non-calculator questions. I have not picked up a calculator once.
Yay.
Okay. So if I have log base 7 of 49 minus log base 7 of 7, that's going to be 49 over 7. So it's going to be log base 7 of 7, which is 1. Now, in this example, you could have actually done this without combining, right? What's log base 7 of 49? 2. What's log base 7 of 7? 1. 2 minus 1 is 1. You could have done it that way as well. But notice in the first example, we couldn't do that. I don't know what log base 5 of 100 is. Like 5 to what power gives you 100? I have no idea, right? So I couldn't do that. All right, so I like to ask these types of questions on the test, on the non-calculator portion. And I always have students that freak out on it and just start doing crazy stuff. And I'm like, I would never ask you to do this on a non-calculator test. Okay, so let me show you what I mean. So I usually give people 3 different things. So in this case, I gave log of 3 is 0.477, log of 2 is approximately 0.301, and log of 7 is approximately 0.845. And then I ask you logs that are related to these numbers in some way. Okay, so the very first one is log of 6. Well, think about 6. How is it related to 3, 2, and 7? Yeah, so 3 times 2 gives you 6, right? So we're going to have log of 2 times 3. Well, based on that product rule, we know that it's going to be log of 2 plus log of 3. So we take log of 2, which is 0.301, and we take log of 3, which is 0.477, and we add them together. That's it. So when we add those, I have 8, 7, 7. So 0.778. I'm not asking it anything hard. But people every single year on the test do 0.301 times 0.477, which takes a little bit to multiply, right? I'm not asking you to do that without a calculator. I'm not asking multiplication, I'm asking addition. Okay, so log of 14. Well, log of 14 is going to be log of 2 times 7, right? So it's going to be log of 2 plus log of 7. So I'm going to get 0.301, and I'm going to get 0.845. And I'm adding them. So when I do that, I add straight down 6, 4, 11, so 1.1. So I get 1.146. That's my answer. Easy to do without a calculator?
No.
No? Yes. So if I have 3.5, I have log of 7 over 2. So this is going to be log of 7 minus log of 2. So log of 7 is 0.845 minus log of 2 equals 0.301. So I have 445. So 0.544 is the answer. How about log of 12? 2 times 2 times 3, right?
Yeah.
Sorry, it's kind of tiny. 2 times 2 times 3. So what's that going to be? It's log of 2 plus log of 2 plus log of 3. So log of 2 is 0.301. Log of 2 again is 0.301. And log of 3 is 0.477. So when I add straight down, I get 9, 7, and 10. So I get 1.079. Okay, and then the last one is where people like totally forget all the things they've ever learned about adding negative numbers or subtracting things with negatives, okay? So if I have log of 2/3, do you guys see that that's going to be log of 2 minus log of 3? Do you guys agree? Yeah, most people on the test get to that point. And then they write 0.301 minus 0.477, and they just forget all rules of mathematics. Like, they start subtracting, and they're like, okay, I have 1 minus 7. I'm going to carry the 1. I'm going to subtract straight down. Why can I not start doing that? What's wrong with that?
Yeah.
Yeah, it's going to be a negative number, right? So if I have 5 minus 7, what I do is I do 7 minus 5, and then I take the sign of the negative, remember? So I'm going to switch it around. So I'm going to have 0.477 minus 0.301. So I don't do that. So I get 671. So I get 0.176, but I know it's negative because I took a small number, subtracted out the bigger number. Do you guys know what I'm saying there?
Yes.
Okay, you can all do that by hand. Don't forget all your rules of math. Now this next thing really does kind of defy the rules of math. Like, it seems weird when we do it. It's something really strange for this property. So let's pay attention to how I'm doing this. So it says, suppose you have log of 10 cubed. If you have log of 10 cubed, what this is log of 10 times log of 10 times log of 10, right? which we know separates into log of 10, or sorry, it was log of 10 times 10 times 10, which is log of 10 plus log of 10 plus log of 10. Okay, but if we have 3 of something, like if I had x plus x plus x, I don't write it as x plus x plus x. I instead write it as 3x, right? So I have 3 log 10s added together. So I write it as 3 log 10. So think about that. We started with something that looked like this, log of 10 raised to the 3. And it became 3 times log of 10. What happened to this exponent? Yeah? Yeah, it turned into a coefficient. It got kind of like pulled to the front almost. Do you understand that? That's allowed. We can do that. Doesn't that seem weird? So like if you have x cubed equals 27, there is no way that we are allowed to say that 3x equals 27. That is not allowed, right? We cannot do that. But we're saying with logarithms we can. If there had been a log in front of it, then we could do it. Okay, this is going to be critical to our understanding of logarithms. So we can pull things to the front as long as we have a log. So if I have log base b of m and I raise it to some number, then what happens is this number can be pulled to the front. So we're going to have c times log base b of m. Okay, and it's because m was multiplied by itself c times, it broke into c log base b of m's, right? That's why it worked. So these examples, again, are non-calculator questions. You should know how to do these. So if you are on your test and you're saying, oh, I have 32 to the 6th, and you're multiplying 32 times 32 times 32, and you're getting some crazy huge number, you were doing something wrong. So if you do that, if you multiply 32 times 32 times 32 and then come to me and be like, but I ran out of time on my test, can I have more time? I'm not going to give you more time because you were doing something not very smart. Do you guys understand what I'm saying? Don't do 32 times itself 6 times. What we do is we pull the 6 to the front. So we have 6 times log base 2 of 32. So then do you guys know log base 2 of 32? Kyle, what do you think? Log base 2 of 32 is? Help them out. Anybody? 5. It is 5. Log base 2 of 32. So when we do that, log base 2 of 32, we're saying 2 to some power gives you 32. So it needs to be 5. All right, so we have 6 times 5, and 6 times 5 is 30. So all without a calculator. So the next one, we pull the 20 to the front. So I have 20 times log base 8 of 64. Log base 8 of 64, we can find that. 8 to some power gives me 64. What power do I need? 2. So I have 20 times 2. So I get 40. The next two are a little bit harder. So try the next one. Think about it. Okay, what we're saying here is that 16 to some number gives me 4. Close. 1/2, that's right. It's the square root of 16, right? 16 to the 1/2. So this becomes 10 times 1/2. So we get 5. Do you guys all understand that?
Yeah.
Okay. All right, next one. So I pull the 6 to the front, and I have log base 27 of 3. 27 to some power gives me 3. What type of root do I take for 27 to get 3? The cube root, right? We know that 27 raised to the 1/3 power gives me 3, because a 1/3 power is a cube root. So I get 6 times 1/3, so I get 2. Yep. Makes sense. Good. You like logarithms. Yeah. No? Mixed reviews? No, I think usually people do quite well on the test, actually. All right, here we go. So there are a couple of more properties. Again, all of these properties that I'm giving you that are in these boxes are very important. You need to know them. Okay, so if I have log base b of b raised to the x, it ends up being x. Okay, logarithms and exponential functions are inverses of each other. It's kind of like multiplication and division undo each other, right? These undo each other as well. Think about what's happening here. The x is going to the front, right? What is log base b of b? Yeah, it's 1. B to the 1 is equal to B, right? So we have x times 1, which is just x. That's why that one works out. The next one is a little bit harder for people to remember. So this is one that you should definitely kind of put on a flashcard or keep in the back of your head, like, I need to know this. It looks strange. So it's b raised to the log base b of x equals x. So it's kind of weird. It's like, wait, the b and the log base b cancel. Is the x just kind of floating off in space then? What's happening? Like, I can't pull it to the front because there's no log up front. Like, what am I doing? Okay, here's what I want you to think of. So think of logarithmic form. So if I switch this around from what it's in now, exponential form, b to some power equals a number, and I switch it to logarithmic form, it would look like this. Log base b, it's b to what power? B to the log base b of x equals x, right? B raised to the log base b of x equals x. Do you guys see what I'm saying? Okay, does that make sense? Log base b of x equals log base b of x, are those equal? Yeah, they're exactly the same thing. That's why this one works. Okay, if you see it in logarithmic form, it makes more sense. Okay, so basically when you see something like 7 to the log base 7 of 2, you should know immediately that it's going to be 2. Okay, the 7 and the log base 7 kind of cancel each other out. You can think of it that way. Okay, so the first one. So I have log base 3 of 3 to the 11. What's it going to be? 11, that's it. So you can think of pulling the 11 to the front if you really want to and saying 11 times log base 3 of 3. Or you can just remember this formula and just say, oh, it's 11. How about the next one? Log base 3 of 81. Nope. 3 to what power gives you 81? 4. So how is this related to the formula that we just did? Well, it's really log base 3 of 3 to the 4th gives you 4. That's what's happening, right? 81 is 3 to the 4th. So I end up getting 4. How about the next one? This is one you just know. 10. What's the next one? 2x minus 1. 5 to what power gives you 125? Nope, 3. And the last one? 7. Good. Are you seeing these? Do you understand what's going to be on the non-calculator? All of these types of things will be on the non-calculator. Good. So we can use our calculator sometimes. Okay, some of you guys are the lucky ones. Your calculator has log base on it. Log base can be found by hitting math. So get your calculator out. Along the left-hand side of your calculator, there's a little button that says math. And you're going to hit math. And you're going to scroll all the way down. At some point, you have something that says log base. I do not. My calculator, it does not have log base. Okay, if you hit log base, what does it do on your calculator? It shows you log, and it has a base. And you can put in whatever you want. So if you want to find log base 2 of 7, you just put it in. 2 and 7. Log base. You may not have it. You don't have a log base, so what do? All calculators before, I don't know, like probably like 2005, all calculators like did not have log base. So my calculator is a little bit old. It doesn't have log base. All right, so we use something that's called the change of base formula. This allows us to quickly put things in our calculator. And it's actually faster than going through math and going down and so on to do this. Okay, so if I have something that's log base b of m, and I want to change it to a base that I can use on my calculator, what base do I have on my calculator? Log 10. So I'm going to try to change it to log 10. So what I do is I do log of b divided by log of 10. That's it. Or not log of 10. What am I saying? Log of m. I'm thinking log base 10. Okay, but you could change it to any base that you want. Another logarithm that's on your calculator is ln. What ln stands for is natural log, log base e. E is called the natural base. Okay, so we could change it to natural log as well. It'd be natural log of b over natural log of m. But I could change it to really anything that I want. It could be log base c of b over log base c of m. Like, it doesn't have to be anything. It can be whatever base that I want. Does this kind of make sense? Okay. We'll explain more about this, why this works, tomorrow when we solve log equations. I think you'll understand when we solve log equations. You'll be like, oh, this is why change of base works. But for now, this is what I want you to use right here. Log base 10. So it's going to be log base b of m equals log of b over log of m. I always remember m is the I don't want to say bigger number. It's the larger font, so it goes on the top. And B was the subscript, so it goes on the bottom. Okay, so it's going down. So if I have log base 32 of 8, what I'm going to do to put it in my calculator is I'm going to do log of 8 over log of 32. So go ahead and do that. So log of 8 divided by log of 32. Your calculator will automatically put a parenthesis here by the 8. You need to end the parenthesis before you divide. Yes?
So if you put the m over b, when you put m over b and change the base from 1, this will be over.
Your base in this case is 32, so it went on the bottom. Oh, what did I just do? Oh, I just did all of them wrong. Oh, no. Sorry, YouTube viewers. Now I'm really confused. I even said the big one goes up, and then I wrote it wrong. Long day. I did. Yep. Yes, Jenny gets a bonus point.
If you watch this YouTube video,
She's famous. Yeah, Jenny, you will hear Jenny's voice. Jenny +1. All right. So yeah, so it's log of 8 divided by log of 32. So try that on your calculator. Kyle, were you raising your hand to say the same thing?
Yeah.
Ah, should I give Kyle a bonus point too? Yeah, Faisal.
0.6.
It ends up being 0.6. That is correct. This one worked out really nicely. It was very nice. It came out exactly to be 0.6. This is because 8 and 32 are actually 2 raised to something. So it worked out nice. But usually they are nice. So this one's going to be log of 40 divided by log of 15. So when you put this in, what do you guys get?
Number.
Like 1 point something.
1 point something? Help me
I
out.
have it on my phone.
Log of 40.
Divided by log of 15.
It's 1.
So 1.362 or 1.363?
It would round down to.
No, it's 1.6. Okay, 1.362.
1.362.
Wait, how do you get
Yeah.
You don't round? Oh, I got
We
it.
round down to 2 because the next digit's 1.
Okay. This took way longer. We're never going to get to our Kahoot game, are we?
No.
All right. So anyway, so we have that. So does this make sense? The subscript goes in the bottom. The thing that's not subscript goes on the top. That's how you put it in your calculator. All right. So we talked yesterday about how we use logarithms for anything that has a scale. So the Richter scale, the decibel scale, the pH scale. And we did the decibel and the pH yesterday, so we're going to do Richter scale today. So it says seismologists use the Richter scale to express the magnitude of an earthquake. The Richter magnitude of an earthquake, M, is related to the energy released in ergs. Ergs is a unit. It's a weird unit. Shown by the formula M equals 2/3 log of E over 10 to the 11.8. An earthquake of magnitude 9.3 formed the tsunami that in Indonesia that happened in 2004. You guys were like babies in 2004.
I was like 7.
So you probably don't remember this.
You were not baby.
So,
You were baby.
oh, okay. You were little. All right. So what we're going to do is we're going to put in, guys, we're going to put in 9.3. So this was a horrible tsunami, and it happened because of a giant earthquake. So, guys, so when the earthquake happened, the earth split, right, underneath the water, and there was a giant tsunami that, like, devastated the community. There were, like, 40,000 people that died. I don't remember the exact number, but it was a whole bunch of people. All right. So we need to solve for E. We want to know the energy released. And we can do this. It looks a little terrifying when you first look at it because you're not used to solving for solving log equations, but we can do this. So first I need to get rid of the 2/3. So what am I going to do? Multiply by 3 over 2. So be active note takers. Try this along with me. Get your calculator out. Try this. So we're going to multiply my 9.3 by 3 over 2. So when we do that, we get 13.95. Okay. Now we're to the point where we can switch forms. It's in log form. There's a log. We want to switch it to exponential form. So what base do I have for my logarithm? Base 10. So I rewrite it. I do 10 to the 13.95 equals E over 10 to the 11.8. Right, I switched forms. Do you guys see it? 10 raised to the 13.95 equals the part that's left. Does it bother you that it's on the left? You can always draw it on the right if you need to. All All right, now we multiply our 10 to the 11.8 over. So I have 10 to the 13.95 times 10 to the 11.8 equals my E. Okay. I'm going to add my exponents. So I have 10 to the 25.75 equals E. That's my amount in ergs. If you do 10 raised to the 25.75, you get a crazy big number. 5.623 times 10 to the 25th. That's a lot of ergs. I don't even know what ergs are, but that's a lot of them. All right, so the same thing on the next one. It says in 1906, a 7.7 magnitude earthquake hit San Francisco. Have you guys ever heard about this earthquake that hit San Francisco?
Yes.
It caused huge fires, ruined the city. The whole city had to be rebuilt. I have a little activity with this earthquake type stuff in it. But basically what happened in the city is insurance at that time did not pay for earthquake damage. It only paid for fire damage. And so people that had their house, if their house caught on fire, they were given money. But if it had just been damaged by the earthquake, they weren't given money. So what people did is they set their house on fire because it was damaged. So if there were pictures of the house after the earthquake and right before all of these fires hit the city, they would not get money. So a lot of people had insurance fraud that happened in that time. So anyway, so I have a 7.7 magnitude earthquake hit San Francisco. So I need to figure out what the energy released is. So I'm going to, again, multiply by my 3 over 2. So I'm going to have 7.7 times 3 divided by 2. So I get 11.55 equals log of E over 10 to the 11.8. My little base is 10, and I switch forms. So Yaya said he likes to see the 11.55 on the left, or on the right. He does not like it over there on the left. So now when you switch forms, you have 10 raised to the 11.55 equals E over 10 to the 11.8. So we multiply over. So I have 10 to the 11.55 times 10 to the 11.8. That's going to be my ergs, my energy. So I get 10 to the 23.35. And I can find what that is if I do 10 raised to that answer. It's like 2.24 times 10 to the 23rd ergs. But what's more important is it says how many times as much energy. So I'm going to break this down and take you back to like elementary school. Livy has 100 jelly beans. Natalie only has 20 jelly beans. How many times as many jelly beans does Livy have? 5. What did you do to get it?
Multiply.
Not multiply. You divided, right? You divided 100 by 20 to get 5. So that's what we're going to do here. We're going to divide. How many times? So I'm going to take my 10 to the 25.75, and I'm going to divide by my 10 to the 23.35. I could subtract my powers. When I do, I get 10 to the 2.4. And if you find that, 10 raised to the 2.4, it's 251.189 times. So not twice as much energy, not even 50 times as much. It was 250 times as destructive as the San Francisco earthquake. Does that make sense? It's a lot. So even though they look close in magnitude, you're like, oh, that's not much, like 9.3 versus 7.7. Those are both big earthquakes. A 9.3 earthquake is terrible. It's very, very strong. Okay, does that make sense? Okay, so get your phones out. We'll try to play Cahoots. Do we have time? We have like 4 minutes.